Welcome once again to my YouTube channel. So today we are continuing with the topic measurement of heat capacity. We have three questions on the board. The very first question here says, what is meant by the statement the specific heat capacity of aluminium is 900 joule per kilogram per Kelvin? Now from the knowledge we got from the previous class, where I explained what specific heat capacity is all about. From that very definition or specific heat capacity, we could be able to put up the answer to this very question, number one. Now let's recall that specific heat capacity is a quantity of heat required to raise the temperature of a unit mass through 1 degree rise in temperature. So if mathematically we say that specific heat capacity is the quantity of heat required to raise the temperature of a unit mass through 1 degree rise in temperature. So having this as a formula of specific heat capacity, where H is the quantity of heat required in order to raise the temperature, then we have M as a unit mass, then we have theta as a temperature change. Now from this we can deduce the very question which reads the specific heat capacity of aluminium is 900 joule per kilogram per Kelvin. Explain. Now look at, we have the specific heat capacity as 900 joule per kilogram per Kelvin. Now, what specific heat capacity being equal to 900 joule per kilogram per Kelvin simply means that the quantity of heat required to raise the temperature of unit mass of that very aluminium through 1 degree rise in temperature is 900 joule per kilogram per Kelvin. Then we have another question on the board. The question reads, write down the equation relating the heat capacity of a body to its specific heat capacity. From the definition and the definition of heat capacity and that specific heat capacity, we were able to deduce two formulas. When you relate both of them, you will fortunately get the question answered. So, in order to answer this question number two, write down the equation relating the heat capacity of a body. Now, from specific heat capacity, we're able to derive equation that mass times specific heat capacity times temperature change is equal to this. We have it as equation 1. So in that case, the quantity of heat is the product of mass, the specific heat capacity, and the temperature change. Then again, from heat capacity, we're able to derive this formula that heat is equal to heat capacity times temperature change. Then we have it as equation 2. Now, when we combine these two equations, we have that the heat capacity times temperature rise is equal to M specific heat capacity times temperature rise. So from both sides of the equation, if you cancel out this very temperature, you are going to have the heat capacity being equal to MC, and that answers the very question number 2. So this is the formula or the equation that relates the heat capacity and the specific heat capacity. Remember, the specific heat capacity is the quantity of heat required to raise mass of any substance through 1 degree rise in temperature. That's the heat capacity. While specific heat capacity is the quantity of heat required to raise the unit mass of a substance through 1 degree rise in temperature. You see the difference? The heat capacity is not interested with the unit mass. Any mass it could be involved. But once it comes to specific heat capacity, then we must be referenced to 1 kilogram mass. So in that very case, specific heat capacity deals on a unit mass, while heat capacity deals on the mass of any substance. That answers question number 2. Then, for a copper ball of heat capacity, 2000 joule per Kelvin. Now, the heat capacity of the copper ball was given as 2000 joule per Kelvin. Is heated from 20 degrees Celsius to 100 degrees Celsius. So it's heated from initial temperature of 20 degrees Celsius to final temperature of 100 degrees Celsius. Then calculate the quantity of heat absorbed. Now, what's the quantity of heat absorbed? Now, from the given parameters, we have that heat is equal to the mass, the specific heat capacity, then the temperature change. We have this as a formula, but with what we are given, you see that we are not going to work with this very first formula. We have another formula that quantity of heat is equal to specific heat capacity times temperature change. So this very formula will be used. Why? Because we have the what? The heat capacity given and not specific heat capacity. So in order to use this theta is the temperature change. So in order to get the temperature change, we have that the temperature change is the final temperature minus initial temperature, right? So at this case, we are going to solve the question. Now we have the heat capacity given as 2000, then the temperature change, we have 100 minus 20 degrees Celsius. So in this case, if you take the difference between 100 and 20, then we are going to get 80. So if you multiply this, 2 with times 8, we have 16. Then you have 4 zeros here. So we now have what? 1600 joule. And that answers the question number 2. Solution to question number 4. Solution to question number 4. What is the quantity of heat required to raise the temperature of 40 kilogram of aluminium of specific heat capacity 900 joule per kilogram per Kelvin by 15 Kelvin? So we have to write down the given parameters first. What is the quantity of heat required? That's H, that's what we are looking for. Required to raise the temperature of 40 kg of aluminium. So we have the mass of the aluminium, 40 kilogram aluminium, or specific heat capacity 900 joule per kilogram per Kelvin. So the specific heat capacity is 900 joule per kilogram per Kelvin. Okay? By 15 Kelvin, that's the temperature change. So the temperature change is 15 Kelvin. Okay? So from the formula, we have the quantity of heat given as the mass, the specific heat capacity, the temperature rise. So here we have to do the substitution. We have the mass as 40 kilogram. Then specific heat capacity is 900. Then the temperature rise is 15. So if we multiply this, we have 40 times 900 times 15. That gives 540,000. Heat is measured in joule. So we have 540,000, or approximately you can convert this to kilogram. We have 540 kilojoule. You convert it to kilojoule because you know that 1000 joule is equal to 1 kilojoule. So we have 540 kilojoule. Then solution to number two. The question reads, what amount of heat was absorbed when the temperature of a piece of iron of mass 10 gram and the heat capacity 200 joule per Kelvin rose from 10 degrees Celsius to 25 degrees Celsius? What amount of heat was absorbed? So we are now asked to find heat when the temperature of a piece of iron of mass 10 gram. So the mass of the iron was given as 10 gram. Remember to convert to kilogram. 10 gram is equivalent to 10 divided by 1000 kilogram. So if you do that, you are going to have 0.001 kilogram, okay? So that's the mass. 0.123. That should be 0.01 kilogram. Then we are given the heat capacity as 200 joule per Kelvin. So the heat capacity, not specific heat capacity. So we have the heat capacity as 200 joule per Kelvin. It rose from 10 degrees Celsius to 25 degrees Celsius. So the initial temperature is 10 degrees Celsius, while the final temperature is 25 degrees Celsius, which means the temperature difference will now be theta 2 minus theta 1. So you solve it, you get the temperature difference as 25 degrees Celsius minus 10 degrees Celsius, which will finally give you, take the difference, you are getting 15 degrees Celsius, okay? So from here, we have the heat capacity, we have the mass, we have the temperature change. Now, because the heat capacity was given, then you work with this very formula, which is heat capacity times temperature change, okay? So here we have the quantity of heat to be heat capacity, which is 200 joule per Kelvin, times the temperature rise, which is 15. I know most of you will like to include the mass, but from what we are given, we don't need mass. So you just solve to get your answer. So 200 times 15, that should be 3000. So we have 3000 joule or 3 kilojoule. Okay, the last exercise there, solution number 3. This one is solution number 5. Here is solution number 6, okay? So here, the question reads, a copper block of heat capacity 600 joule has a specific heat capacity of 400 joule per kilogram per Kelvin. Calculate the mass of the block. So we write down the parameters. A copper block of heat capacity. So we have the heat capacity as 60 joule per Kelvin. Has a specific heat capacity to be 400 joule per kilogram per Kelvin. Okay? Calculate the mass of the block. So looking at this, we have the heat capacity, we have the specific heat capacity. You need to get the relationship between both. From the formula, we have the relationship between specific heat capacity and the heat capacity. That specific heat capacity, we derive the formula there. You remember where we said that if we have the specific heat capacity to be this, then being equal to heat capacity, which is this, then we cancel out these very words, temperature differences. So in that case, we have the relationship between specific heat capacity and the heat capacity to be this, where this C is the specific heat capacity, C of P is the heat capacity. So we now need to do the substitution in order to get the mass, or simply make M the subject. If you divide both sides by C, you now have that M is equal to heat capacity divided by specific heat capacity, okay? So the mass to be obtained will now be heat capacity, which is 60 joule per Kelvin, all over 400 joule per kilogram per Kelvin. So if you divide this, 60 divided by 400, 60 divided by 400, you are going to have 0.15 kilogram. If you convert it to gram, then it now becomes 150 gram. So that answers the question. So if what we did, we're able to entice you, please do subscribe, share, and turn on notification for others to learn as well.